Okay, hi all. So, bringing back to the memory management section once again because I think something was left in that. So let's see one question that was that we talked about in the last lecture, and that is all about how we are arranging organizing the main memory with the pieces of RAM. Okay, so the question was we want to have a main memory. Okay, so we want a main memory with a capacity of 4 megabyte. Now we all know 4 megabyte is nothing but 2 raised to the power 2 multiplied by 2 raised to the power 20 byte, that is 2 raised to the power 22 byte. Okay, so we want this capacity for our main memory. Okay, now we have to create this main memory, we have all pieces of DRAM chips. Okay, now this DRAM chips will be having its own capacity, and that is 1 m into 1 bit. So that is equal to 2 raised to the power 20 bit. Please note that this is bit and this is byte. Okay, now first question comes that how many DRAM chips will be required to create this main memory with capacity of 4 megabyte, right? So for that we already have seen in previous video that number of DRAM chips required will be equal to 2 raised to the power 20 into 2 raised to the power 3 upon 2 raised to the power 20 into 2 raised to the power 0. Now, from where did it came? So, it came from this. We want a main memory capacity of with 2 raised to the power 20 rows, and each row having 2 raised to the power 3 bit. I mean, the capacity needs for one row. And currently, we have DRAM with each row 2 raised to the power 20 and 2 raised to the power 0, that is 1 bit for each row. Okay, so from this we get that let me it's 22, right? So it will be 22. Okay, so it will be 2 raised to the power 2 and it will be 2 raised to the power 3. So altogether we have total number of DRAM chips will be 2 raised to the power 5, that is 32 DRAM chips will be required. So the number of DRAM chips will be 32. Okay, this is clear. Now, let's see about how the memory is going to be organized with the help of this DRAM chip. So, we have this DRAM chip consisting of some 2 raised to the power 20 rows, and each row holding 1 bit of data. So from this, if we want to constitute a main memory, what we have seen that our main memory will be constituting of 2 raised to the power 2 rows and each row with 2 raised to the power 3 data. So let's create this. So we have this 4 rows, 0, 1, 2, 3, and each row carrying 8-bit data. That is actually 1 byte, but let's see in terms of bit. Okay, so I think 0, 1, 2, 3 up to 7. Okay, so this is the memory constraint of this, and for this we need a decoder, of course, and that decoder would be something 2 into 2 to the power 2 decoder, that is 2 into 4 decoder, to decode these addresses, and each addresses will be holding each bit of data, something like this, right? So it came from here, number of rows into each row holding how many bits. Now the question that we stuck in the previous video was about the refreshing time. Okay, so each DRAM chip each DRAM chip, if the configuration for each DRAM chip is given as having 1k row of cell. Okay, so this is the row of cell and 1k cell in each row. So that is the column of cell. So it's something like this one. So this is 1k row. Okay, 0 up to 2 raised to the power 10 minus 1, and this each row is divided up into 1k column. So 0 1 up to 2 raised to the power 10 minus 1. So this is the configuration. Now for each refreshing all these entire cells, so time required to perform for a single operation, so single refresh operation is 100 nanosecond. So 100 nanosecond is required for one refresh operation. Now one refresh operation is being performed for one cell only. Okay, so this is one cell. Okay, so for this cell, if 100 nanosecond is required, I mean this is the time taken to perform a single refresh operation for this cell. So for this entire block, how much time will be required to perform the refresh operation for 2 to the power 10 into 2 to the power 10 cells, that is equal to 100 into 2 to the power 10 into 2 to the power 10. Okay, so this is the refresh operation time for this one DRAM chip. Okay, now for the memory, we already have seen how many DRAM chip required. It is 32. So if we talk about the time required for performing the refresh operation for the entire main memory, is we need to perform for all the 32 DRAM chip, and one DRAM chip requires 2 to the power 20 into 100 nanosecond. So entire memory will require 2 to the power 25 into 100 nanosecond, and that I believe will be equal to 32 into 2 to the power 20 into 100 nanosecond. Okay, so we can convert it like 3200 into 2 raised to the power 20 nanoseconds. So this will be the answer for our question. Assuming that this 100 nanosecond is the time required to perform the refresh operation for this cell. Okay, so in the question it was given the time required for single refresh operation. So that means it is assumed that for one cell the refresh operation time will be 100 nanosecond. Okay, so this is the solution for that previous question we talked about in the last video. And this is all about the memory organization. So I'm concluding here. We'll talk about the loading, linking, and address mapping scheme in the upcoming video. So please keep watching and do like, share, and subscribe for more videos like that. And thank you very much for watching this video. Thank you.